This video is about ionic compounds. In the previous video we looked at what ions were and how to draw ions, and this time we're looking at how these ions would bond together to make a compound. Now, a compound itself is when two or more elements chemically bond or chemically combine. Often in an exam question, the definition of a compound would be a 2-mark question, and you need the idea of it, the fact that it's two or more elements and that they are chemically combined to gain both marks. An ionic compound is a compound which is made up of ions. And ionic compounds always exist between metals and non-metals. For example, you could have the metal lithium, and that could be ionically bonded to a non-metal, for example fluorine. So we could simply write the ions in short form by looking at the group that the lithium and the fluorine are in. Lithium is in group 1, so it will give away 1 electron and become a plus ion. Fluorine is in group 7, so it will gain an electron and become a minus ion. Alternatively, we could draw the ions in brackets. So lithium would give away its outer electron and become a plus ion, and fluorine would gain an electron. Now this electron is all often drawn as a circle instead of a cross to show that it's a different electron which it has gained, and again the brackets here would be a minus. And now this makes a little bit more sense when you draw them both together, because it shows where the electron from the lithium ion has gone. So there used to be an outer energy shell on this lithium with an electron in the outer shell, but this electron has been transferred to the fluorine atom to make it a fluoride ion. Often ions have the ending "ide", so this is a fluoride ion, whereas we say this is just a lithium ion. So the electron from the lithium has been transferred to the fluoride ion. You now have a case where you've got Li+, or a positive ion, and a negative ion. And you can see in this circumstance that the positive ion would be attracted to the negative ion, and this is where we get that ionic bond. And there's a special force called an electrostatic force that exists between a positively charged ion and a negatively charged ion, which makes the bond really strong and keep the ions together. We'll look in a later video about the structure and properties of ionic compounds, but in this video I want to focus on being able to draw the ions that exist in a compound and then be able to write the compound formulae. What this means is, how would we write the compound of lithium and fluorine together? Well, lithium fluorine would make a compound which ended in "ide", so it would make a compound called lithium fluoride. And we need to be able to write that as a formulae, and to do this we need to know how many lithium ions and how many fluoride ions go together in the ionic compound. And all you do is look at the charges. So in this case we have got 1 plus and 1 minus. Therefore one of each ion will cancel each other out. So we would only need Li and F. And this would be the formula for the ionic compound lithium fluoride, LiF, because you've got one positive charge, one negative charge, and they cancel each other out. So the idea is you want no overall charge on the compound. In a different example, you could have sodium, which is our metal, bonding with oxygen, which is our non-metal. Now this would make an ionic compound called sodium oxide. Now if we were to write this in shorthand, sodium is in group 1, so it would be Na plus, but oxygen is in group 6, so that would need 2 electrons to complete its outer shell, so that would be O2 minus. Now in this case we can't just take 1 sodium and 1 oxygen, because we've got a plus and a 2 minus. So we need to make sure these are balanced out. So to balance out a 1 plus with a 2 minus, we'd need 2 sodium ions. So the compound formula for sodium oxide would be Na2O. Really importantly, you only write the numbers at the bottom. It's not like balancing equations where you write the big numbers in the front. This is all about writing what the actual compound looks like. So you only ever put the small numbers, subscript, which means lower down, next to the ion which you want to multiply. So we need 2 sodiums and 1 oxygen. So now we've got 2 Na pluses and 1 oxygen with a 2 minus. So our pluses are now 2 plus, and our negatives, our negative charges are 2 minus, and now the 2 pluses and the 2 minuses will balance out. So some more ionic compounds here: sodium chloride, magnesium oxide, calcium chloride, all ending in "ide". You should recognise that ending as the ending for an ionic compound. And we again got a metal bonded with a non-metal. So sodium chloride consists of the ions of sodium and chlorine. So in an exam you might be asked to draw the ions that exist in this compound. So if we take sodium, for example, sodium ion, to have 2 in one shell, 8 electrons in the last shell, remembering our brackets, and that would be plus, or simply in shorthand that would be Na plus. If we take chlorine as an ion, that would be a chloride ion, and that would have 2 in the middle shell, 8 in the next shell, and 8 in the last shell, because that electron that sodium has lost has been gained by the chlorine atom to make it a chloride ion, and this would have a charge of negative, which would be Cl minus. And if we were to write the compound formula for sodium chloride, sodium has got a +1, chlorine has got a single negative charge, so together they would make NaCl, because you just need 1 of each. You wouldn't need any numbers here, because 1 plus balances out with 1 minus. Now have a go at drawing the ions, the simple form, and the ionic compound formula for magnesium oxide and calcium chloride. Pause the video now. So for magnesium, you would have 2 electrons in the middle, eight on the outside, but because you've lost 2, you become a 2+ ion, which would be Mg2+, and in this case you're bonding to oxygen, which would have gained the 2 electrons that you've lost, and become a 2- ion, which we'd write as O2-. So together we've got a 2+ and a 2-, so we just need one of each to balance it out, which gives us MgO. For calcium chloride, we need to draw a calcium ion, and because that's in group 2, that will be a 2+ ion, Ca2+, and this is bonded to chlorine, and the chlorine is in group 7. It gains 1 electron and is a minus ion, which is Cl-. So one of the electrons from calcium has gone onto the chlorine, but there's another one, and because there's another one you need 2 chlorine ions. So, and you can see this here because you've got Ca2+ and Cl-. Now when you put these together in a compound, you have to have the charges balanced out. You can't just put CaCl, because you'd have an overall charge which would be +1, because you've got more positives than you have negatives. So in this case you need 2 chlorine ions, or chloride ions as they're called, to balance out the calcium ion. So you need CaCl2. This 2 means that you've got 2 chloride ions and just 1 calcium ions, but you never write the little ones there. It's just like algebra, you don't write the ones, you only write it if it's a number bigger than 1. So in an exam you might be asked to draw the ions that exist in these compounds, or you might be asked to work out what the compound formula is, and in this case you need to use your periodic table, which will be provided on a data sheet. Just to add, it's better practice to draw one represented as dots and the other represented as crosses, and you might see this kind of thing in your exam. So not to get confused, if you see electrons drawn as circles or crosses, they mean the same thing, but it just helps us to see where the electron transfer has occurred. For example, if we took our previous example of sodium, if we drew the sodium ion with dots instead of crosses for the electrons, we could then show the chlorine ion or chloride ion as crosses, and the final electron that it's gained you could show as the dot. And this shows us therefore that the electron from sodium, from the outer shell of sodium, has been transferred to chlorine. So don't be put out in the exam if you see some as dots and some as crosses. In fact, this is slightly better representation because it helps you to understand that this electron that the chlorine has gained has come from the sodium, and again that Na and Cl would make us the sodium chloride.